Today we're going to talk about compound probability and the multiplication rule. So remember that I have a compound probability when I have multiple events and I'm looking for specific outcomes in each event when I need both things to occur. I can use the multiplication rule when I have a compound probability and I have already closely considered how the two events relate to each other. Are they independent or dependent, or do I need to have them in order? Important things to consider when you're looking at this and trying to use the multiplication rule. So you've seen this example before. If I have this spinner, I spin it twice. What's the probability of a red and a blue? If I spin it twice, what's the probability of a red and then a blue? So before we've looked at this with the area model. Say spin 1 and spin 2, here's a list of all the possibilities. And we found that of a red and a blue, you can either get blue and then red, or red and then blue. That's 2 out of the 16 options. If I need a red and then a blue, there's only one option there, 1 out of 16. Let's look at how we can use the multiplication rule to make this a little bit easier. So if I spin the spinner twice, what is the probability of getting a red and then a blue? You'll notice that I flip-flop these two questions. That's because in order, using the multiplication rule is easier if you need them to happen in order, and I'll show you why. The multiplication rule just says that we're going to take the two probabilities, the individual probability of each thing happening, and then multiply them together. So you have to remember how to multiply our fractions, which is just numerator to numerator, denominator to denominator, so straight across. So if I spin this spinner, what's the probability of a red and then a blue? Well, what's the probability I get a red? That would be 1 out of 4. And then a blue. Well, what's the probability I get a blue? That is also 1 out of 4. So then all I have to do is multiply those. You'll see 1 times 1 is 1. 4 times 4 is 16. 1/16. Is that what we got before using our area model? It is, red and then a blue. There's only one option, 1 out of 16. The difficulty comes when they don't have to be in order. That allows for a lot more options, as we've seen in our different models. There are different ways to get the same thing. So we have to consider that. So what we're going to do is say, do I care if it's a red or a blue on the first one? I don't. Right? If I get a red on the first one, then I care about the next one, it has to be a blue. But I could also get a blue on the first one and then only care about the second one. It would have to be a red. So in this case, I don't care if it's red or blue on the first one. It could be red or blue. So the probability of a red or a blue, it would be 2 out of 4. And then on the next one, I do care. If this is a red, then I need the probability of getting a blue. If this is a blue, my 2/4 chance, then I need to multiply by the probability of getting a red. In this case, it's the same each time. So 2/4, and then the probability of getting a red or a blue would be 1/4. And the same down here. If I got a blue on this one, then the probability would be 1/4 here. So again, you'll see 2 times 1 is 2, and 4 times 4 is 16. That's 2 out of 16, which is 1/8, which is what we got here. 2 out of 16. The important thing, the thing that makes this a little more complicated when I don't care the order, is that you have to consider that when you're finding your probabilities, that I don't care about the order in this first one. Okay, red or blue is 2/4. Then I have to care about the next one, considering what I got in the first. If it's a red, I need the probability of blue. If it's a blue, I need the probability of a red. You're not going to know that. Don't sit here and say, well, what did I get on the first one? That doesn't matter. It's 2/4 that I get a red or a blue on the first one, and then 1/4 that I get the other on the next. Let's consider our other example of flipping a coin 3 times. This is one we used a probability tree for. Here's a list of all the things that could happen, and let's consider some that we've looked at already. So what is the probability? Let's look at all tails first. Are these independent? Do I need to have them in order? Well, since they're all the same thing, I don't need to worry about order. So I can say, what is the probability of all tails? So I will just multiply the probability of a tails times the probability of a tails times the probability of a tails, which would be 1/2 times 1/2 times 1/2. So when we're multiplying straight across, I have 1 on top. Out of 2 times 2 is 4 times 2 is 8. 1/8, which is what we have in the last scenario using the probability tree. There is 1 all tails out of 8. Let's look back. Tails, heads, tails. Well, in this case, it'll be probability of tails times probability of heads times the probability of tails, and that will be 1/2 times 1/2 times 1/2, which is still, again, 1/8, which is what we had. For this one, probability of at least 2 heads, there's actually a lot going on when you're setting up these probabilities that you're going to have to multiply. There's a lot of things to consider, so we're going to save something like this for a later date. But I want to show you here, okay, we have 1/2 times 1/2 times 1/2. This turns into 1/8. Let's see how the probability tree helps us make sense of this. So of course here, you either get a heads or a tails. That's 1 out of 2 options. You will get 1 out of 2 options here. From that, there's 2 options here and 2 options here. So there will be 4 now. Each one of these doubled. So if each one of those doubled, then I have to double the amount of options. 2 times 2 is 4. There are 4 options now. And if these 4 options then double after that, for a heads and a tails for each option after that, then I have to double all the options again. So it goes from 2 to 4 to 8. And that'll keep happening. However many flips I have, the options, there'll always be 2 more options for each of the previous 2. So you'll see this is 2 to the first options, 2 squared options, 2 cubed options, 2, 4, 8, etc. You would multiply by 2 each time because each one of these gets 2 more options off the end. And that's going to happen every single time. So this is what happens here with this multiplication rule, and this is why it works. So to recap, I have compound probability when I have multiple events and I'm looking for specific outcomes in each event, and I need both things to occur. I can use the multiplication rule when I have compound probability and when I have closely considered how the 2 events relate to each other. Are they independent or dependent? Do I need to have them in order? So remember, if you're considering something like this, I don't care what happens first, but I will care what happens second. So make sure that you consider that when doing your probabilities with multiplication rule.